Hello guys, today we have an autopilot on the bench. It's a Neco made in England model. I have no idea. This is so old that my grandfather used to be a virgin when they built it. So the first thing, took the cover off. I want to see what's inside, what's going on, how does it work inside. We'll take it everything apart and see if there is some way to connect two wires to the motor and to the clutch. I think this is the clutch. I have no idea. It's the first time I take one of these apart. They're so old that I did not even consider them until now. Now I have this one, and I want to see if it can be recovered. Take all the old crazy shit apart and off and see if it can be used only as an actuator with modern electronics. Maybe can give it to someone that really needs it. Now I'll start taking it apart and I'll see you in a little bit. A satisfying moment, it's when you cut the red wire. Should I cut the red wire? Should I cut the red wire? Should I cut the red? I cut the red wire. Yeah, fuck it. Let's just cut everything off. Oh my god. What was inside here? Now, the guys that used to work on this type of autopilots, they must be really mad. Now, standard rotation, and you had a connection type and reverse rotation. So many freaking cables inside. Everything should have been, I think it was like almost, woohoo. These are thick wires. These other ones are thick wires also. All analogic stuff. Yeah. Destroy everything. Now, let's just put an old school everything tied up, like in the helicopters they used to build the wiring like this, everything like tied up. They will used to be even like contests who make it nicer. I must confess, I'm a little bit envious because I don't have the patience to do things like that. Now, they're so neat. Yeah, that was a fuse. So neat done. Fuse. Okay, let's just see what's going on here with this board. Yeah, all type screws, like flat screwdriver. And keep in mind one thing, probably this one was built before the standards. They were before the standards, so every type of screw, it has his own measurements. This is a really old school diode. Let's just see here what's going on. Yeah, I'll just take everything apart and be right back with you. Now, I took out the two screws and took this board apart, but I have no idea what is going on here, because there's still a lot of wires that going inside all this connection. Wow, it is a little bit more complicated than I was expecting. Now this one, it's a power contactor. Maybe it can be reversed. Maybe it does one way and the other. I think so. Let's just take the screws out. This, yeah, insulation there. Yeah, it must be, because it has double contacts. It has this one that's normally on this one, and then has this one. So what I think it's going on. This one should be one of the bobbins, and I think that on this central piece will be the motor wires. This one, like the motor wires. So what's going on when you energize this? Should be connected to negative, I think, always connected. So the motor has two negatives if you connected here on the central one right now when this staying still. When you connect one of them, this one should be a positive, goes positive on one wire and negative from the other. And when you do the other way, this one switches to negative and that one with positive. So this is an inverting relay. Okay, so let's just take it apart, because we might connect it. Can be useful from some automation or something like this. We'll see how many amps does it have in order to understand how can we use it. No, yeah, fuck it. There it goes. So we have a red, that's one. We have the other wire, that's this one, a black, that goes from here. This is one. Red and black is the second bobbin, and then we have 6 wire, 2 in, 2 out. Maybe we'll see it later. Let's see if it does have some code for those playing along from home. UK, Potter and Bromfield, UK. PR 20,000. This is solidly built. It has a little bit of, can you see it? Tack. Yeah, it's in focus. It did arc a little bit, so there's a piece melted, but seems like one of those old things that always keep working. Now here we have this thing, we have this other thing. I have no idea what these are. This one, it's connected to the case, okay, and then we have a lot of wires that are going down. One of them was loose. This is why it's not working. One of them was loose. Yeah, these systems were long way before my time. This one was also loose underneath. So if it did not work, was another one. What the freaking? I did not lose them. They were all loose inside. Now this one also, we don't need it. Okay, now we have another wire that is going down here. Okay, let's just cut everything, including the red wire. Cut the red wire, cut the red wire. Okay, everything is cut. Look how nice it is. Instead of the cable ties, they used a cord. So nicely, all tied up. Yeah, this is like aircraft type of work. Let's just take out the screws. Yeah, and we have all this upper panel. We'll just take it out. See you later. Now, one other thing to see is all these spacers, everything, these are machined, and in those times they did not have a lathe that was automatic, CNC machines. Everything is done by hand. So someone took this piece, just work on it, make the threading on a lathe or some kind of machine, thread the other side, drill the hole, like this one also. So much machining inside one of these things. Imagine how much work they put into building all this thing. Like everything tied up by hand. It was before the PCB. They didn't have the PCB, and they had like binding posts and pass wires and solder. Everything built by hand. It's so fascinating. I have no idea what these two things are. Maybe they're a couple of switches or something. It might be. They might be some end of switch, because this did not have an electronic system for one side and the other. Now we have a lot of wires here. I have no idea where these are. Just take this a little bit of greasy thingy. What is this? Grease. Let me just take this cover out and I'll be back with you. Yeah, and what do you know? It's not a metric bolt, although made in England. It's some kind of inch measurement, but I do have a Torx, and the Torx goes in. I think I can manage to open them up, yep, with the Torx. Yeah. This is the second one, because it has another ones that are under. If you don't take out this one, you cannot reach the other one that's on an angle. Well, at least it seems like it. I don't know, it's so dirty. I expect having that it must have something like oil inside. Some threading compound. Don't you see? I think. Yep. Okay. Now, 2 small screws here, and then these 4. Yeah, by the looks of it, it is like some kind of inch threading. It's not a normal one. I should have some... Ooh. There's some kind of spring inside. Let me first... Okay. Let's just see what will come out of it. Interesting. Those are not switches. These are 2 copper rods. They have the brush like the brushes in a DC motor. This one are touching a slip ring inside, and there's oil. Wow, it is oil inside, has oil. What kind of oil is that? Red. Vampire oil. Okay, so we know that it has some vampire oil inside. So I think the motor shaft. Now this one, it is the clutch. On these 2 are the clutch slip rings. I think if we put like, I don't know if you can see it. Let me just try to put something under it. His own piece. And let me grab some power thingies. Now if I turn this one, it just turns freely. And I think if we power these two, we'll engage the clutch. I think this one here, it's a clutch. We just take some 12-volt 2 wires. I have a 12-volt battery here. Let's see if I can. Yep. Okay, so we know that the two slip rings are the clutch wires, and inside here at this point I think it has only like some kind of encoder or stop when it reaches one side or the other. Mechanically it seemed really nice. It has a worm gear in the output of the motor. It's really nice gearbox inside. Now I know that that one is the clutch. I'll just close it temporarily because anyway I will make a proper gasket and see where it has the filling, the filler for the oil here. I don't think so in this one. I just don't want to get dirt inside. And we'll see what all these wires here are for. I think at this point that it will have some kind of temperature protection, the way it is built. We will, if will be used, I will give him a proper cleaning. I will redo the gasket, proper oil. If it has seals, I think it will have seals on the shaft's outputs. I will do those also. These are plastic insulated. It's a bit difficult to reclose it with those two in place. I think when I'll properly close it, I'll install them afterwards. Yeah, now it's going. Okay. It has a drainage. I see a drainage plug. I did not read the fucking manual, RTFM. And these spacers that used to have it here threaded, I think they were acting as plugs, so I think we might need to put them back. Okay. Now this mechanical part here, I think it is some kind of encoder or stop and stop. Let me just take out these two lateral plates and we'll see what's going on. Now that I know that it has oil inside, I don't want to lean it too much. Maybe I could just this one is a little bit difficult. Just a little light tapping, it will loosen them a little bit. Yep. Okay, I suppose there will be brushes inside. Yeah, there are the brushes inside there. So all I have to do is find this wire from one of the brushes and the other wire from the other brush. There's a little bit of dust inside, but the brushes don't seem to be so consumed. So it did, like, I don't know, maybe 40 years this thing, maybe more than 40, and it is still in good shape like this. It's unbelievable. It was built really good. Okay. I'm curious most of all. Yep, there is a little bit of dust. It has two. Let's just see if it has more than two brushes inside, the carbon brushes. Now, in any type of DC motor in the boat, it's good practice, just a couple of years, 2-3 years, take it apart and clean the dust from the brushes. Now, this dust is conductive because the brushes must conduct electricity to the rotor of the motors. Yeah, only has two brushes, not four, and I think these two thin wires should be the power. What are those other for? Two of them might be some kind of temperature sensor, the red ones. Let's just see what's going on. Nothing. So I don't think are those two. Let's just see directly on the brushes. I should go grab a multimeter, but it's just faster making some sparks. Yeah, sparky. It's like blocked. Doesn't want to spin. Maybe I don't have. Yeah, doesn't want to spin. It's really strange. I should take the cover off again and see what's going on. If I manage to. No, that's not it. I should take the cover off and see. It will everything go into a real autopsy and repair. Let's just see. Maybe it might have some blocked brush. I have no idea. Usually when you take a wire and put it on the two brushes, no, already. Let me just take this cable out. Yeah, what the fuck? It has a counter. Yeah. It is spinning freely. Maybe it has some kind of other connection inside. I have no idea what is going on with this electric motor. What type of electric motor? Cannot be a brushless. Must be a brushed. No. Yeah, I'll grab the multimeter and start poking around a little bit and just see what's going on. Maybe those other two wires. Yeah, give me just 1 second. Yeah, I have no idea what's going on with this type of motor. The black ones, the two blacks are the ones that are going directly to the brushes, but the gray ones, I have no idea what they do. Really strange. Now I'll take it apart and see what's going on. I got an idea. More power. Jeremy Clarkson way. More power. Let's just put a bigger battery. Either we're making bigger sparks or it starts spinning. Nope. Just bigger sparks. The other one? Yeah. Now I definitely have to take it apart to see what's going on inside. I have no idea how this motor works. Yeah, I guess we'll figure it out. The first thing is just try to understand how to freaking take it apart. It has one small screw here and then has another 3 of them that are holding the back panel. Let's just see. Seems like a PH type or PZ Phillips. Okay, now that's interesting. It has some kind of spacers inside. Yep. So it's pre-compressed with spacers. Ooh. Then it has a small one here, and then it has these ones. I think it's a 10 mil. And 11. 12. It's not 12, it's some kind of inch. I do have the inch one somewhere. Yeah, at this point I have no idea what is going on there. It's not. I didn't even take some pictures of how the electronics used to be connected from the big contactor. That might have helped us understand how this motor works, but this is another way to understand it. They just take it apart, that way we'll see how's inside, if it's bad or it can still be used. I think it can still be used, I hope. The mechanical gears are built really good. Yeah, I think it's missing a little bit of there is the drain. This is from the top to fillet. There is the drain, and here there is a small one. I think this is the level, and it has another one on down as a drain. Let's just see what's going on here, if everything comes out or yeah. It's a good thing that I'm using a tray underneath, because all the oil it's getting out. Okay, so we have the vampire oil inside. I should have drained beforehand, but that's why I have the tray. I guess we'll do it the other way around. We'll do it afterwards. It has a gasket. Yeah, it has some pre-tension on the bearings. So those spacers are important. These ones, let's just not get them wet with the oil. There's preload on the bearings. Okay. There's a paper gasket that we can redo. It has some kind of insulation, something like this, or gasket material. They use the brush to brush it. Okay, wow, this is really interesting. What I'm seeing here, it seems like this is not a permanent magnet motor, might not even be DC motor. It does not have a permanent magnet, but it does have an inside. Really strange. Now let's just put the back cover on. There's no need to take it apart, but who knew? Okay, just put that thinner one inside. Okay, so now that's really interesting here. This is not a permanent magnet motor. It has two separate windings, so I guess one of them will be the field that makes the stator, and at this point I have no idea what was the voltage. That's why it has double connections for forward and reverse, because in the reverse must have the stator connected on the other way around. So now that we know that's a permanent magnet that doesn't have a permanent magnet, you can see it from inside here a little bit. There's a second winding that's inside, so one of them must be like temperature sensor or something like that, and the other one, I think it is, let's just see if it goes with 12 volt. I think one of them, I will have to, no, this one with this one, and this one with this one. Just see what's going on if we power them both together. So power to one and power to the other. No, maybe put them in series. Yep. Okay, so in series. Let's just see what's going on if I invert this one with this one. It goes in the other way around. So, now. Okay. If I reverse polarity though, what's going on? Reverse it. No, really strange, really strange. I don't know if you can see it. Now, if I connect it like this, let me see, it spins this way. If I reverse polarity here, it spins the same way around. The only way to reverse it's just to switch these ones, and now it reversed. If I just reverse polarity, it will spin in the same way. This is really strange. I think this one should be a temperature sensor. So at this point, how WTF do we command this thing with reverse polarity? I have no freaking idea. I have no freaking idea, because a reversible system, a modern system, it has a reversible motor that spins one way or the other when you reverse the two cables. This one needs to invert these two here to make the two. Guys, I have no idea, but I will sleep on it. Now we don't take it apart further. I'll just put it back in. I'll drain the rest of the oil. Let me see if I find something, and I'll just put it all provisory in a box while I'm thinking how we can use it, if we can use it with modern electronics. Yeah, and I'll be back to let you know. Right now I'm really dazzled, because it was a thing that I did not expect it. I think we can build an adapter plate on the gearbox and just take this worm out, since it only has one bearing. We can take the worm out and connect another motor here on the gearbox. Is really smooth, really nice and smooth as a gearbox, and it has a clutch, so it has all the elements. All we need is just a round piece with the motor attached with two bearings, and just close the lid off, and that's it. But let me think, how can we use just one thing before closing the video. I'm curious how many amps is this drawing. Let me just put it back on the gearbox really fast, and then I'll back. I did just put a smidge of liquid moly. That way, if I decide to throw a little bit of oil inside and just play with it, will not go out again after I clean that one. Now, I was curious. The clutch, it's drawing 1.2 amp at 12 volt, 13 volt. So that's good. We can use it. The clutch, it's good. Now, I'm really curious. What's the power draw of the motor? Ooh. It's more than 10, and it goes down to 7, like when it's spinning. And this is without clutch and without any force. It is really a lot. And the worst stick is that is not. I'm trying the other way around. What? Doesn't want to go anymore. Maybe the battery it's. Yeah, it's really high. I do have a video somewhere. That I used as temporary measuring. What the fuck am I doing? No, one here. Yeah, it goes like 25 amp when it starts, so will be like at least 15 amp of draw. An S3, I think it could handle it. It will be really interesting to put a smaller motor in it and just reduce a little bit the dimension. I think that's about it with this one. Let me know in the comments if you know something more about this type of motor with non-permanent magnets, with winded stator, and how can I maybe use it in a reversible manner. I think we could do it with a couple of diodes, but yeah, I don't know. Let me know if you know more than me about this in the comments.